Welcome everybody to my talk 10 SQL tricks that you didn't think were possible. The other title of this talk is also 10 SQL tricks to convince you that SQL is an awesome thing. And I'm sure you will be convinced at least that it is awesome. Whether you like it or not is a different question. A little bit about myself. I'm Lukas. I'm from Switzerland. I'm the CEO and founder at Data Geekery, a small company in Switzerland. We do a lot of SQL consultancy, also in the Java ecosystem. We have our product called Juke, which you see on my T-shirt. I'm a Java champion. I'm also a Juke Switzerland board member, where we organize events in Switzerland with a lot of members. I personally believe that SQL is a device whose mystery is only exceeded by its power, and today you will certainly agree with this as well. Why do I talk about SQL? This is a Java conference, and I do talk about SQL. And some of you came here. I was surprised not more because everyone uses SQL, right? Everyone uses SQL. Why do I talk about SQL? SQL is the only ever successful mainstream and general purpose fourth generation programming language. So the only declarative language that is really, really mainstream. Prolog never got it into mainstream. All those other languages, Datalog never got into mainstream. SQL got into mainstream, and it is awesome. Why doesn't anyone else talk about SQL? I don't know. Everyone uses it. No one talks about SQL. Everyone used to talk about NoSQL databases. Now this hype is over again. But still everyone talks about, uses SQL. No one talks about it. What is SQL, ladies and gentlemen? SQL is the original microservice. Right? Just install a single store procedure into your Oracle Express Edition instance and deploy, and you're done. That is a microservice by definition. Who thinks that this here is SQL? Anyone thinks this is SQL, right? This is a SQL statement? Okay. Who thinks this is how you do SQL nowadays? Who does SQL like this? REST? ORMs? Like this, maybe? Is that how you do joins with SQL these days? Yes? Anyone? Think again. This is wrong. This is not SQL, ladies and gentlemen. Now, when we talk about SQL, neither the first statement nor what we've seen before is SQL. Why am I saying this? Are you still using Windows 3.1? No, you're not. So why are you restricting yourselves to SQL 92, the old SQL standards, to those primitive little features that were there forever? SQL has evolved, and I stole this slide with permission by Markus Winnand, who's a SQL performance consultant from Austria. Very interesting content. And he also talks about modern SQL like I do. So this is a SQL statement that I like. What does this calculate? You in the front rows have already mentally processed this SQL statement, and you came to the conclusion that the output of this is the Mandelbrot set, right? So when we zoom into this, we see this beautiful display of the Mandelbrot set. I stole this from a blog that I've linked on the top here. It is a very easy SQL statement. You all agreed to this. So this is a SQL statement that proves that SQL 99 is Turing complete, right? No one in here realizes in their everyone work that SQL is actually a Turing-complete language. So what does that mean? Turing completeness, next time you go to a party, you know what to talk about when the alcohol flows. You can impress everyone with your knowledge about Turing completeness in SQL. So what does that mean? Any program can be written in SQL, right? Just because I can doesn't mean I must, but you could write your whole program in SQL and it would compute. Seriously though, what is the advantage of SQL? You tell the machine what, not how. You tell it, this is the result. It has these constraints, please solve these constraints for me. And I'm not talking just about the where clause. There are many, many constraints like exists and complex predicates, and not only predicates, but also other expressions that you want the machine to resolve for you. You don't care about the algorithm. You don't care about nested loops or hash joins or whatever, and in which order you want to collect the data. You just tell the machine, this is the results. Do with it what you want. And when you think about it, what do you prefer? This approach to computing? Or that one? Yeah? So make your choice. Declarative programming is awesome, and there's also one reason why this company was called Oracle. You just ask the Oracle, and it tells you the answer. You don't know how it got the answer. It's just the correct answer. But what's the problem with SQL, as we're seeing today? This is the problem with SQL. So everything on here that is green are keywords. So what we modern developers like to criticize with SQL is that it's ancient. It reminds us of this kind of language, where we also had a lot of keywords, and the syntax is awkward, and it doesn't fit well into modern functional programming languages and everything. The other thing is declarative thinking is hard. So you would like to tell the machine, okay, go over there and do this 5 times and blah, blah. You think you like that, but after a while it gets complex. So declarative thinking is hard indeed, but it's always rewarding, because when you do reporting with SQL, it's very easy. Reporting with SQL is very easy. Bulk data processing with SQL is very easy, right? Ad hoc analytics is very easy. So when you have a normalized database and you want to quickly find out how many people have this kind of constraint and this kind of property, and you aggregate that and you do something like that, ad hoc analytics is very easy. You just drop that SQL statement on your data. You don't have to program hard, complex programs. And by very easy, I obviously mean hard, right? But it's still easier than doing that with imperative or object-oriented programming. And I say also you don't have a choice. That's the only language there is for this kind of thing. So I have a quote here from Winston Churchill: SQL is the worst form of database querying except for all the other forms, right? So today, you came here not to hear my evangelism only, you came here for the tricks. Before the tricks, I want you to be sure, lean back, use this thing. So this is what is called the SQL muscle. Every one of you is equipped with one SQL muscle. It takes a lot of training and practice, yes? You don't get good at SQL by just staring at it. You have to practice SQL all the time. And eventually get better because the underlying concepts are very easy. So as I told you, this is enough of the blah blah. The introduction, I have to be fast today. Yesterday, I figured out I have only 45 minutes. This talk is usually 60 minutes, and it's a very fast-paced talk, so I'm sorry if I'm going to be overwhelming you, but these are the 10 tricks that we're seeing today. 10 tricks to convince you that SQL is awesome. This list, some of you take pictures, the slides will be online as well. It's a very complex list of nice things. The main thing to remember here is SQL is really awesome. This awesome. Okay, so trick number one. Most of you know this, right? So everyone knows this statement. The trick is everything is a table in SQL. Now, when you see this, can you identify the table? Who can correctly identify the table in this statement? Yes, person. You are all right. But who would have said that this here is the table? This is also a table. Very right. So in SQL, everything is a table. That's a very nice concept. So you can put this table, which is called a derived table, in the from clause to make it a derived table, and you can select from it again. You can also put this values constructor in the from clause in some databases. Not all databases support this. This is part of the SQL standard. Only SQL Server and Postgres are the popular ones that support this. Some less popular ones also do. You can just create an ad hoc in-memory table just for this use case. When you just need a little bit of data, you want to join that to some other table, it's very easy. So the values clause, you may know me from statements like insert, is actually a table. When you run insert, you're inserting a table into another table. Think of it this way. It's all about sets. SQL is about set theory, so you're not inserting a single row, you're inserting a table that just happens to have a single row. In Oracle, Oracle helps you keep your fingers busy. You can type the same thing, but still it's a table. And in Postgres, for instance, even this is a table. Any function in Postgres is a table. It's just a one-by-one table, but this is very powerful. This concept is very powerful. You can join one-by-one tables with other tables. Very, very useful. When you go back to Java, this is probably the only Java slide in this talk. We now also have something like tables in Java 8. This is the stream API that was added, so you can actually do the equivalent of SQL to the stream API. So a table is a stream of tuples. If we did have a tuple type in Java, we could do it this way. Then you do select. That's the same thing as map. And when you think about it this way, map returns a new table. When you do map in Java, you get a new table. When you do select in SQL, it's also a new table, except the syntax is a bit clunky. You don't see that immediately, but actually conceptually, it's the same thing. And all of the statements are equivalent. So you can have join in SQL, you have flap map in Java. Of course, Java is not a declarative language, so be aware. When you do flap map, you're actually doing a nested loop always, right? But conceptually, they're the same thing. So a little side advertising here from our side. We have a product called Julambda. It's open source. It does better streams for you. So if you have the SQL mindset, which is the right mindset, and you want to program Java because you have to, you can do a lot of SQL-y things much easier in the Streams API with Julambda. All right, that was trick number one. Trick number two, common table expressions. They're the only way to declare variables in SQL, and few people know that, and few people use them as this, because when you build up a huge SQL statement, they're very useful to cut down the problem into smaller pieces. Afterwards, you have to optimize again. They're harder to optimize still today, but they're very good tools to get started with a huge SQL statement, because you can structure your SQL statement with the with clause, and then you have a table expression, T1, which is a variable, and you can use T1 in T2. You can reference these variables from the other variables, and in the end, you just select from all of these tables. Now, the one thing that I really appreciate with common table expressions or with this with clause is that some databases, or most of them actually, also implement the recursive form, and this is the recursive form of a common table expression, as you can see here. Yes? Okay, so I stole this joke from Hadi Hariri. I just love this. It's a very good joke for this kind of slide here. But the thing is, a recursive common table expression always has this union all statement. So you have two subqueries. The first subquery needs to be the seed row or the seed rows. So it's the initial data set over which you want to recurse. And the second subquery of the union all statement is the recursion. And the recursion is defined here. As you can see, I'm selecting from the table that I'm about to declare, right? So when I do this, I can access the previously declared variables and increment this by 1. So I get this nice list of integers here very easily in SQL. Oracle has a special syntax for this, so if it's very easy iteration style recursion, you can use this. It's preferable in Oracle. When you have complex recursions, you better not use connect by. You use the with clause, right? So when we go back to this example, we've seen it all. We've admired this beauty. We've seen here, this is also with recursive. So the Mandelbrot set is a very wonderful example of recursive SQL because it's defined as a recursion that either converges or bails out. So we can do that with SQL very easily. If you agree on the easy part, it's a different question, but it's actually rather easy, actually. So applications for recursive SQL, iterations from 1 to 10, or generating all the dates in July. If you don't have them in your table, you want to have them pre-calculated in memory. That's one example. Or generating graphs. You can do, if you have just a few graph database queries, you don't have to install a graph database for that. If they're not very, don't have to be calculated very efficiently, SQL might be just enough. Right? Okay, trick number 3. And it's really fast-paced, as you see. You don't have time for questions, really not. It's too fast-paced. What is a running total? A running total is something that your project manager can explain to you because it's very easy to do with Microsoft Excel. In Microsoft Excel, you have these kind of values, and you can just say, OK, this value is equal to the two values above subtracted from each other, and then you take the crosshair, and then you run through your spreadsheet, and then you have the running total, right? So this way you can calculate the balance of the amounts recursively again. So this is a running total. Everyone is clear with a running total is? How to calculate those? We could do it with common table expressions, but there's a much, much nicer feature in SQL called window functions. So who in here does know window functions? Oh, many of you already do. Wonderful, wonderful. So who doesn't know window functions? So it's about 50-50. So for some of you, this is not news. For the other ones, it is news. For those of you for which this is news, please remember there was SQL before window functions, SQL after window functions. These are even more powerful and simpler than common table expressions. Remember these two features. What are window functions? They're aggregations or rankings on a subset of rows relative to the current row being transformed by the select. So this is a lot to digest if you've never heard it. You can access, in short, you can access rows relative to the current row. So you can look ahead or behind and do aggregations or rankings on these windows. So for every time you select something, you have something like a moving window, and you can do aggregations within that window. And the syntax is actually very easy once you get used to SQL, right? Once you get used to the keywords, it has a function and then this over specification. And it consists of these 3 parts. The first one is the partition. So you want to only restrict the window that you're sliding to the same partition. It's like group by. So when you calculate something on these films that you have here, on the films, when we zoom in, you can see I partitioned by length. So the partition or the window only includes those films which are of the same length as the current film. So when I do something for something which has the length 46, I will only see those rows. The same with 47. And you can see within the partition, I can order the partition. So the partition is ordered, and this is independent of the outer query. So just for this one calculation, I can order this partition. And finally, the third clause, I can restrict the frame or restrict the window to so many rows ahead or so many rows behind or the total or whatever. So this is the number of rows ahead and behind that I want to include in the ordered partition. Now, most of these clauses can be combined independently. In some functions, they're independent. You can add them or leave them away with sensible defaults. Finally, you actually do the calculation. So in this example, I'm just calculating a row number for the ordered partition. And you can see 1, 2, 3, 4, 5, 7 is done independently of the first partition, which has row numbers from 1 to 5. This is an extremely, extremely useful feature. Not every one of you who has never used this will immediately see this, but during the talk you will realize this has changed SQL forever for those databases that implement it. So window functions are aggregations or rankings on a subset of rows relative to the current row being transformed by select. Very, very nice feature. So how do you do a running total with SQL? We have here bank account transactions. And we want to calculate the balance, as we've seen before. So we know the current balance. In this example, you can calculate the balance either top-down, if you know the current balance, or bottom-up, if you know it started with 0. In this example, we're going top-down. And for instance, this balance on row number 4 is equal to the top balance, the current balance that we know, minus the sum of all the amounts that are on top. Right? That's correct. So the window function that we're doing here is the sum of amount over this window, which consists of the partition. We don't want to have the neighbor's bank account transactions. We only want to have our own. So we only want to calculate the data that belongs to us. Then we order this partition. We only want to have those ordered by date, which are on top, and then we restrict this window to have only the dates on top. So I'm aware this is very fast. You can read the slides again later on. Important is for you only to remember that 2 very advanced SQL features that you should all remember and use more often. Recursive or non-recursive common table expressions. Beware of optimization things in these depending on your database. And window functions, which are often very, very fast because they run in memory, if you're not nesting your selects too deeply. But if it's a top-level select, window functions are very fast. Right, so the next tricks. You have now the tool set for the next tricks. Let's do just the rest of the all, how to draw an all. And don't worry if you feel like this. Experience comes with practice. Remember the SQL muscle. So we have Stack Overflow now, a Stack Overflow example. Wonderful. We have someone from Stack Overflow here. He can explain you how they do it behind. I imagine they do it like this. So we have batches on Stack Overflow. So one batch that you obviously all have is the enthusiast and the fanatic. Some of you also have because you're visiting 100 days, one after the other. Without, you ignore the birthday of your wives or whatever, or the wedding day. You ignore it, you go to Stack Overflow. If you miss one day, you don't get the batch. So, right, for instance, me, I have all these batches. I have a lot of reputation as well. And how do we calculate this? Right, so this is the login times, right? We have the login times. We don't care about the times. Maybe, yeah, I know early morning. We only care about the dates, so we know how we do this. This transformation is very easy. We do just select this thing. We upcast login time to remove the timestamp information, and then we get the dates. Now we want to do these row numbers. Why do we not do that? We'll see. But we want to calculate the row numbers based on the ascending order of login date. So it's easy. We learned now this is row number over the window that is ordered ascendingly by login date. That calculates the row number. Now what happens if instead of selecting these two things, we subtract them? In most reasonable databases, subtracting an integer from a date gives us another date because the integer is the number of days. And what we get here is some random dates. We don't care about the dates. But the interesting thing is 14 minus 1 is 13. 15 minus 2 is also 13. But suddenly 18 minus 4 is 14. So when we have a gap that we all see with our minds on the left side, but the machine, how does it detect the gap? It doesn't just know, but we've seen it. On the right side, on the other hand, when we subtract it like this, we do get this gap as well. Huh? Very, very nice. So row numbers are consecutive. Huh? The reason why this works is row number never has any gaps. That's how it's defined. Row number is a consecutive, continuous series of integers, depending on your order by clause. And our data, however, does have these gaps. So whenever we have the gaps, and it's not consecutive, we get the gap. And we can order by, we can group by these random dates, do some aggregations, and we get this result. The longest series of consecutive login dates with no gaps can be found like this, right? So this is the full query. You will have to optimize it a little bit. This is just a trivial example how to explain it. It's very easy, as you have seen, if you're used to SQL, so you will write this right away, right? So the difficulty is obviously to get the idea how to solve the problem, but when you have the solution path, it's very easy to write with SQL. Okay, harder problem, finding the length of a series. So the length of the series that we have here are these. We want to calculate these lengths of the series. And if you're observing closely, what is the series? The series is 2 times the positive amount, 3 times the negative amount, 2 times the positive, negative, positive. Just a random definition of what is a series. And how do we calculate this with SQL? For instance, we can pre-calculate these values again. So we don't care about the exact amount, we just care about the sign, which is what defines a series, positive or negative. And again, we're doing the row number thing, right? That's easy to calculate. We do it like this. Most databases have a sign function. Otherwise, you have a workaround to calculate this sign function. Now the harder part. One example of how to solve this would be by calculating these low and high values on each row. So what is low? Low is when we're on the first row of the series, we want to have low to be equal to the row number. Otherwise, we ignore it. When we're on the last row of the series, we want to have high to be equal to the row number. Otherwise, we ignore it. And so on and so forth. You see, row number 4 doesn't have any value because it's not the lowest nor the highest value in the series. So that's what we want to achieve. So this example here, low and high is the same. And 99 as well. So how do we do this with SQL again? So those of you who know window functions will immediately scream with, yeah, which ones? Lead and lag, exactly. No one said it, but there, you can come up. And there, because lead and lag are very useful window functions. Now that we can order the window and access the next and previous rows, we just have functions to actually access those rows, right? So you don't have to sum stuff. You can just take that row and the value in it. So we can, for values 1, 2, 3, 4, we can check out what is the previous value and the next value and put that in the same row. That is very, very not relational. Like relational algebra, and that's not possible with this. SQL is more than relational algebra. Some people argue that it's a bad thing, but it's very, very useful. So now that we know how to do this, we just take the lag of the sign, so the previous value of the sign, ordered by this ID, and we check if the previous value of the sign is different than the current value of the sign. So that will mean that we have the low event, and the high event is the lead of the sign, so the next value of the sign, being different than the sign is the high event. Obviously, we have to check for null, so this is a little bit of a boring code here, and we get the example that we had before. Next step, we want to have something more advanced. We don't want to have just the low and high events at the beginning and the end. We want to fill up the whole series with those values. So this series here, the first 2 positive amounts should have low and high values being equal on each row. And the same here, 3 and 5 on each row. And again, obviously, we're using window functions. This time I'm using one that is not available in all databases. In this form, unfortunately, I'm using a special ignore nulls clause. So I'm going through the window, but I'm not considering the null values in the window. I'm taking the last value for low, except the nulls, over the window that is ordered again the same way for all the values on top. So this is a lot of keywords. Don't learn them right now, learn them afterwards. Null handling again. But the concept here is this. When I'm on row number 5, I want to go up until I reach the last value of all the low values that is not null. So I'm reaching the 3. I'm going up to reach the 3. The other way around with high, I'm going down to reaching the 5 because that's the first non-null value in that window. So when I do this, I get the filled up gaps that I have here. And finally, I'm just doing this trivial last step, 1 plus high minus low, don't forget off by 1 errors, gives me the length. Trivial, huh? You have to think of it. This is not necessarily fast. Depends on your database. But the idea here is very interesting. It's very interesting to think of SQL this way. You can access the next and previous values. Huh? Okay. Still everyone okay with this? I still have some time left. I have this problem here, the subset sum problem. I asked the author of XKCD for permission to post this. Unfortunately, he's never very much available. It's not allowed to publish comics and commercial incidents, so please check out the definition of the subset sum problem directly on that URL or on, for more boring explanation on Wikipedia. Subset sum problem comes down to this. I have these results, right? So these are the results I want to get to, and I want to combine these items and summing them up to get the closest sum to one of these totals. That's the subset sum problem. There are different ways of defining the subset sum problem. Usually you want to have the exact sum. In my case, I want to have the closest sum, and you all mentally process the result already. So this is the result for this sample, right? Exactly, it's very easy to calculate subset sums. The naivest possible algorithm is exponential. That's the one we're looking at today. This is not at all performant, obviously. There is a polynomial algorithm that is approximative, and it would probably fill the whole talk to explain it. So I'm skipping that. It's this one that we're solving, to the power of n subsets, and we need to sum at most n elements, right? So you're all ready. We just calculate the sums, and then we just calculate the closest sum, and then we're done, right? We already have the toolkit. Now we can do it. So how to do it? Yeah, it looks like a university example, right? I'm just trying to prove and make a point here. It's possible with SQL. You probably wouldn't even solve this problem because it's exponential, but it's possible with SQL. And always remember, you can always do anything with SQL. So in this example, I'm just quickly skimming through these because it would take too much time today. But essentially, you're just adding one item and then maybe the next one to a sum. Or you can skip items, then you have a new sum. So all of these are valid sums. And in the end, you just, for each item, you say, is it in the sum or not? That's the algorithm, the naive exponential algorithm. It's very easy to program with any language, also with SQL. So with SQL, you would use a recursive common table expression. So this recursive keyword is not necessary in all databases. In this case, I'm using Oracle. So this means I'm defining the sums table as being all the sums that are possible. And this is the first iteration here. So the first iteration is all the individual items. So each of these are a possible sum. That's easy. And then I recurse on each item, and I take all the items that are on top of it. So you see the recursion happens here. I'm selecting again from sums. I'm joining all the items again at each recursion, but I'm only selecting those items that are higher. As you've seen in the previous slides, I'm going down in the items list. When I recurse, the sum itself in the first recursion is the item. In the next recursion, it's the item plus the sum that I've already had before. That's how you do the sums recursively. The highest ID that I've had so far is just the ID of any recursion. And finally, I'm doing this nice little toString operation here to display the concatenated list of items to get the sum calculation formula. So this is how to calculate all the sums. How do I find the closest one of these totals? It's not so difficult anymore. It's not using any fancy SQL. I'm just doing here a very trivial cross join. So I'm combining each of the totals with each of the sums. And in this example, I'm finding the minimum absolute value of the difference. So these will give me the best differences. That's the easiest way to explain it in the next step. For those of you who are not very fluent with SQL or cross join, what is a cross join? When you have a deck of cards, a cross join is like the ranks cross joined with the suits gives you all the cards. So you have 13 ranks and 4 suits, you get these cards. Nice example on Wikipedia. That's a cross join. So we've seen how to calculate the closest, the best difference, but we want to have the best sum. Here I'm using Oracle syntax. Don't worry about syntax, it's just the idea of finding within each group the best value. But you don't care about the value, which is the absolute difference. You want to have something else at that position. So this will give us this result, right? So the total query is very simple, if you look at it. There are a lot of keywords you might not have seen yet, but the query itself is very simple, and you just tell the machine what. You have never told it exactly how. Yes? Are you all feeling you should do the next task with SQL? Right. Okay. Next trick. The running total must be less than 0. Okay? So we have this table here again, always the same table, but now we have amounts that go below 0, and we don't want them to go below 0. We don't have any credit with the bank. They don't allow us, so we just go to 0. So you see this on some lines that are marked in red. We want to cap the running total on the lower end to be 0 or the actual value. Right? Everyone clear with the requirement? So in Microsoft Excel, this would be, again, very trivial. You just do an if inside of each cell, and you do the running total again, and then you would always take the greatest value of 0 or the sum that you calculate on top or below. So Microsoft Excel, ladies and gentlemen, is the first application that's been really mainstream reactive programming. No one thinks about Microsoft Excel when they hear this buzzword, but reactive programming means you have a cell, you modify it, you have dependencies, all the dependencies update automatically. You don't care about these things, so this is reactive programming. We can do reactive SQL, ladies and gentlemen. So how to do it? How do we do it? Will we use window functions? Probably possible, maybe not. It's very, very hard. I'm saying it's probably not possible to do this in a reasonable algorithm. It will kill the database, maybe. I've not tried it yet, but would you use recursive SQL? Yeah, it's possible, absolutely. That's a very good use case for recursive SQL in an exercise, but it's not geeky enough. Are we going to use obscure vendor-specific SQL? Of course we're going to use that, because someone else will maintain it, right? And we're this girl here, yes? Okay, so what we're using is Oracle. We're using Oracle for this example. Oracle has this model clause. And you can put model after each table, and that's a wonderful thing, because model is actually spreadsheets in the database. So it has these main 3 clauses after model. It has a huge amount of clauses that I'm not explaining here. It's probably a known programming language actually inside of SQL, but these 3 are the ones that you have to specify, and they're easy to understand. So the dimension clause is just like in Microsoft Excel. You have dimensions of your spreadsheets, right? In Microsoft Excel, you only have 2 dimensions. Usually you use only one of them as a dimension and the other one as a measure, as we've seen afterwards. In Microsoft, in Oracle database, you can have as many dimensions as you want. You can calculate string theory stuff with 11 dimensions, very easy. Measures are the values in each cell. So in Microsoft Excel, you only have 1 value in each cell. With Oracle SQL, you can have a tuple, so you can have as many values in each cell as you want. That's very useful as well. And here, the rules are a list of rules, unlike in Microsoft Excel, where you have the rule inside of each cell. But it's the same thing, so you can have as much powerful rules as you want in this list. Now let's solve the exercise. We're first adding just this total column with a derived table. Remember, everything is a table, so we have a new table that has the total initialized to 0. And then we add model. The dimension is trivially row number, so we just add this row number again. If anything you remember from this talk is tomorrow you will start using row number all over the place. But row number is a perfect solution for getting dimensions because it's consecutive, has no gaps, and it doesn't have duplicate values. So we're using row number. The measures are all of these columns. We don't really use the measures feature here. It's just all the columns that we want in the result. And finally, we have this small little rule where we say total of any dimension value. So at any position, the total is defined by the greatest value of 0 and the total of the current value of the row number. So at the current, it's hard to explain. Just remember it's CV of the row number. You go up 1 column plus the amount of the current value, and then you're done. That's the Microsoft Excel way. You actually just pulled the crosshair across your database table, and you're done. Again, with this boring getting nulls right in SQL, and you remember reactive SQL, this is the future, ladies and gentlemen. Okay? If you want to learn more about model, just read this white paper. Don't copy-paste the link. Just Google Oracle Model White Paper, and you will find a very well-explained white paper about model. Okay, time's running up slowly. We still have 11 minutes. This one I'm going to go through rather fast. Some of you are perhaps in fraud detection, or maybe you do analytics, real-time analytics on a lot of data on your bank account transactions, or you want to do stock exchange analyses, you do time series pattern recognition. Now this is a very specific domain. If I have these these data again, I might want to have a trigger that happens at some event. And the event here, if you look closely, so we have again series with lengths, and the event here is, when we go from bottom up, it's the 3rd repetition, right, of this minus sign. And in words, the trigger, we want to have a trigger on the 3rd repetition of an event if the event occurs more than 3 times. So it's kind of a problem. you might not immediately jump to solving it with SQL, but if you already paid billions to Oracle, you can do it very easily. Again, with this, remember, vendor-specific obscure SQL, and it's extremely interesting. It's really extremely interesting. This time we're using Oracle 12c Match Recognize, a new feature in the new version of Oracle. Who's using Oracle here? Some of you, so you can profit from this tomorrow. If you're using 12c, you can immediately use it. Match recognize is also a clause put after a table, so you do match recognize, you order your table again. So this is the pattern matching order. You do again measures to have the columns that are produced by this, all rows per match. The pattern is the interesting clause where you put regular expressions, right? So when you do pattern matching, the best language for that is regular expressions. And define is a list of event definitions. So are you ready for the solution? Okay, you're not, but I just have to keep moving here. So this is the solution we want to have. I put it up there on the top right. So first we order by ID. This is obvious. We want to match by ordered by ID. Then we want to have the trigger being defined as this classifier function. That's actually the definition of the event. So we'll see afterwards what it means. The pattern is this. So we have a start event, optionally followed by this event, combined RXR. So R stands here, it's just my notation, it stands for repetition, and then X is the trigger that we want to have, and then R plus means it must be more than 3, right? So I have another repetition, maybe 4, 5, 6. You will have to read the white paper anyway, don't remember all the details, but these events are both the same, R and X, they only differ in the way that I name them, so I can use them differently in the pattern. They're both, the sign of the amount of the current row being pattern matched is different, is equal than to the previous sign of the amount, right? So when it changes, I don't have the events. When it stays the same, I have the event. This is the full query. This is the result. You can see the pattern matching works. So the only place where it really matches here, it doesn't match because I don't have the R plus fulfilled. So I always get this start event. Here I have the result, what I'm looking for. Yes? And because I don't care about R and S events, I just remove all that's not X, and I get this result. So that was extremely fast. I just wanted to show you that these kind of things are also possible in SQL, especially if you're using Oracle. So we thank Oracle for this nice feature, right? And if you're interested, read the white paper. Everything is very nicely explained, step by step, much, much slower to read than in this talk. Just Google Oracle Match Recognize white paper. Now that you're experts with SQL, the following is also almost trick number 9, too embarrassingly simple. I'm almost ashamed to present to you pivoting and unpivoting. So we have this table here. You have actor names with films and ratings. So this is the age that you have to be to watch the film. How do we do this pivoting, for instance? We want to calculate how many films of each category did the actor play in. And we don't want to have that normalized, but we want to have that as a nice pivot table, because that's how we want to present it to the user, maybe. This is pivoting. Unpivoting is the opposite. So when we have pivoted, we can also unpivot again and transform the columns back to rows. That's pivoting, unpivoting. It's almost too easy. With Postgres, you have this syntax. So with each aggregate function, you can append a filter. This is also part of the SQL standard. Unfortunately, none of the other databases have implemented it yet. You can just add a predicate for each aggregate function, and then you can easily, with a bit of typing manually, create the pivot table, right? If you don't use Postgres, all the other databases support this syntax. That's a very easy syntax. It's just 2 characters more than Postgres, as you can see. So Postgres doesn't save you from a lot of typing, but it does separation of concerns. Few people might know that when you have an aggregate function, specifically count doesn't count the null value. So this case expression makes everything null that is not the desired value, and then you don't count those. That's how you pivot in most databases. If you have one of these 2, they have a special syntax here. So again, you can amend your table with this pivot keyword and then do the calculation, the aggregation directly in this pivot clause. So you pivot the count aggregate function for the rating in the list of these values. It's a bit of magic. It's not very, very usable, But sometimes when you have these kind of reports, and it's ad hoc SQL that you're writing, especially with ad hoc SQL, this is very useful. Unpivoting is just the opposite, right? So you can see it's just everything inverse. So remember, pivoting is transforming or transposing values from single columns to columns containing aggregations, and unpivoting is the opposite. That's almost too easy. Last trick, XML and JSON in the database. You all came here for this, right? Because you finally want to get rid of MongoDB, and now you want to do JSON back with your IBM instance, DB2, which has JSONX, something like that. First, a word of truth in this talk. Be prepared for this. JSON is just XML with less features and less syntax. This is the truth, ladies and gentlemen. And now, remember, since XML is awesome, you all agree with that. The corollary of this is JSON is also less awesome. Never forget. The only reason you're doing JSON is because you're writing JavaScript in your browser, and who likes to write JavaScript? Everyone, no one. So go back to XML, because with XML you have XSLT, which is the only thing even more awesome than SQL. It's a forgotten technology, but it is so awesome. I could fill even 5 talks about XSLT. Now I'm running out of time. I can't show you the details of this example. I'll just show you it's possible. So this is the XML document. We have a nice list of actors and films. It's not normalized. We have a comma-separated list of films in each actor. Horrors to parse, right? You have to pattern match these commas, and when does a film title have a comma, what happens then? But we want to have a normalized result of actor ID, first name, last name, and then, no, it's denormalized actually, sorry. And then we want to join the film IDs in different columns. So what we do, again, easy, common table expression, recursive, this is using Postgres syntax. I'm having 3 common table expressions here, indicative. The first one just parses the XML. Now I have an XML data type. Easy with Postgres. Second one just uses XPath to transform the XML columns in SQL columns. Most databases have an integrated syntax, so Postgres has just ordinary functions here. I think SQL Server is more integrated with XML, the same with Oracle. It's also very integrated in the SQL standard. This is different in every database, but you can always do it. So here we have a table for the actors, and I don't have the films yet, so the films is very easy. We just do a couple of regular expressions, right? So pattern match the comma-separated values recursively until we ran out of films, right? So a word on regular expressions, right? So this was the full list of 10 SQL tricks that to convince you that SQL is awesome. So some of you, I was lying, that you didn't think were possible. If you know window functions, you've already seen some of these things, but I wanted to convince you that SQL is awesome. What does awesome mean? I checked out the dictionary. Awesome, you can't write that without writing awe. So awe is a feeling of fear and reverence. You all agree, right? So you're also all amazed, and you can't write amazement without writing maze. What does maze mean? Maze is a labyrinth, a puzzle consisting of complicated blah, blah. I like the third definition. It's confusion of thought, perplexity, uncertainty, and state of bewilderment, which you can't write. Okay, I'm stopping here. Why do I talk about SQL? SQL is the only ever successful mainstream and general purpose 4th generation language, and it is awesome. Now, all of this I've shown you today, I didn't say a single time, do I want a nested loop? Do I want a hash join? Do I want whatever? I don't care about algorithms. I just tell the database, this is my data. I wanted this form, give it back to me. And that certainly is awesome, right? Why doesn't everyone else talk about SQL? I still don't know. You're all here because you're at the Java conference. You are asking yourself, can I write SQL with Java? Of course you can with our product called Juke. Juke is a domain-specific language, an internal one written in Java, which compiles SQL code directly into Java. So your Java compiler can compile SQL code because all your tables and columns are generated. There is a second talk by myself. Come see it at 14:55. Coincidentally, the same time at Hibernate talk. You don't have to listen to the Hibernate talk. Just come listen how to write SQL in Java. And what's the key takeaway of this talk? Number 1, can you do it in the database? Yes, I've proven it. It's Turing complete. You always can. Can you do it in the database? Some of you already can. You know these things. Some of you have learned something. If you are overwhelmed, please come see me, and we find a way to give you a 2-day SQL consulting or training. We do that also in our company. It's a very good training. It's much slower paced than this one. Can you do it in your database? Yes, of course, unless you're using MySQL, which doesn't have any of these features. Should you do it in the database? Why not? Because you're not maintaining the project, right? So you don't have these discussions. Do listicles attract attention? Yes, they do. They do work. You're all here because of the top 10 title. And will this talk ever end? Also, yes. Thank you very much. These are my coordinates.